Okay, so like part 2 of notes, start here Friday, note to self there. Again, planned on getting all the way through, didn't happen, but no big deal. We'll finish it up, and then you'll have time to work. I'm recording because I post every lesson that we do. I didn't do it yesterday because I messed up the recording, but in general, I'll record every lesson that we do. That way, if you are out for school or sickness or whatever, you can find it in Schoology and get caught up. Especially if you're one of those that gets sick multiple days and you really don't want to fall behind, you can find the videos posted and stay caught up. A few people also use the videos at the end of the unit to review. That seems a little overkill to me. But if there's like one topic you were like, man, I really wasn't sure about that, then I do have students go back and watch, the videos from previous in the unit to study. So they give you a ton of resources. Use what you need. All right, relations and functions. I guess we better be clear that those are not the same thing. A relation is a set of ordered pairs, like input, comma, output, x, comma, y, any combination of x's and y's. Domain and range we talked about yesterday. The domain is the x values, the range is the y values. Relations can be described by, or you might say given by. We could give you the graph. That's probably our favorite, because then you're looking at it. Give you an equation, give you a list of ordered pairs. A mapping diagram, that would be, an example would be down here at the bottom. That's a mapping diagram. A table, I'm not even sure what a written rule would look like, other than maybe like a word problem that leads to an equation. So any combination of x, y is a relation. A function is a specific type of relation where each x value corresponds to exactly one y value. So, to me, the easiest way to think about functions is the vending machine example. Have y'all heard of that or seen that? Okay, a couple of nods. Where there's buttons and there's drinks. So I got button 1 and 2 and 3. We'll make this a simple vending machine. And your options are A and B. If you press button 1, you get drink A. You press button 2, you get drink B. You press button 3, you get drink B. So do you know, is that a function? Is that an example of a function, or is that a non-example? It is a function. If you know what you're going to get, it's a functioning vending machine. Right? In fact, we have a lot of vending machines that don't even have A, like those water vending machines, like every button leads to water, but it's still a functioning vending machine. You know what you're going to get. So that is a function. Do you know what we would need to draw for it to not be a function? Okay, starting with this one, if we also had an arrow from 1 to B. That's right. Let's do it that way then. And at that point, it doesn't really matter what 2 is doing. That's not a function. Because, I guess we get send 2 to B. Not a function because if you press button 1, you don't know what you're going to get. Right? Or you get both, which would be a great vending machine, right? You push one button, you get a Coke and a Dr. Pepper. Like, that's a winning day for you. But that's not a functioning vending machine. So, a function is you know what you're going to get. Each x leads to exactly one y. If you got an x going to 2 different y's, that means you push the button and got 2 things. Or you push the button and didn't even know what you're going to get. That's not a functioning vending machine. All right, back to the words on the page here. There's only one output for each input. For every x, there's only one y. For every girl, there's only one guy. I don't even know what that is supposed to mean. I don't like that one. Because that one doesn't really work backwards. I mean, who's the x, who's the y? I don't know. There's a special type of function called a one-to-one function. And one-to-one function, it's nice when we name things by what they are, so you don't have to like memorize something. 1-to-1 means they match up 1-to-1. So if we've got buttons 1, 2, and 3, and we got drinks A, B, and C, they match up. There's not. It means each Y also has only one X. It means the backwards is a function. You can go backwards. A 1-to-1 vending machine means if someone's standing there holding a Coke, you could tell what button they pushed. That's a 1-to-1 vending machine. Those vending machines that are all waters, that's not 1-to-1. If someone's standing next to that vending machine holding a bottle of water, you don't know what button they pushed, because there's 10 options that are all water. So that's not 1-to-1. It's a function. Like when you push a button, you know what you get. But if you can also think backwards, then it's 1-to-1. And again, it's called 1-to-1 because it's a 1-to-1 mapping. Okay, let's see if we can apply that stuff to a set of points here. So 6, 4, 1, -5, 6, 1. See if we can do this without. I mean, you could draw them all out, but that would be a little bit overkill. Is this first one a function?
No.
Why not?
Because 6 has 2 lines.
Yeah. If you push the 6 button, you get a 1 and a 4. So that's not a function. And if it's not a function, then it can't be 1-to-1. So this question is not applicable. That is an irrelevant question if it's not even a function. Now, it still has a domain and range because those words go with any relation. So the domain is the x values. So we just list the x's. I'm going to list them in order. I say in order. I'm going to list them in increasing order, but sometimes people will just list them in the order that they're given, and it doesn't matter. There's not a preferred way to that. It's just whichever way makes more sense to you. My brain wants to organize them and put them in numerical order, but your brain might see it better as just writing them down in the order that they appear. Also okay. Range is the y values, and same thing. You can put them in order kind of on the fly here, or you could just list them out. And I guess at the risk of being confusing, I'm going to do it the other way on this one, because it does not matter if you put them in order or not. So maybe it's easier to just list them. Maybe your brain wants to put them in order, whatever you like. Okay, how about this second option here? Is this a function?
Yes.
Yeah, because each x only goes to one y. So yes, it's a function. Is it a 1-to-1 function?
No.
No, because, well, you tell me, why not?
Because the 4 has 2 different x's.
Yeah. So if someone's standing next to that vending machine holding a drink of 4, you don't know if they push the 2 button or the 3 button. We would not be able to go backwards. It's not 1-to-1. All right. Domain, that's simple. That's just the x's. 1, 2, 3. The y's. And don't list them twice, so just 2 and 4. You don't have to list the 4 again. All right, why don't you try the next 2? Those go pretty quick, I think, so you try the next 2.